So we're doing a section of today's lesson on how to do the classification of different equations, and also how to identify those classifications, what makes those classifications work. So I wanted to start with something very, very simple. We've got our first equation here, and second equation here. Now, let's see, David, could you tell us, how would you classify equation number one? Decomposition. That means you're taking one thing and making two from it. Is that what you meant?
Oh, no.
Okay. What do you think this might be then? Synthesis. Now, why is it synthesis? Shh. Let David struggle with this. Do you have your notes from yesterday?
Yes.
Get your notes out. Everybody should have their notes out. Those notes from yesterday are important. And for those of you watching on this video, I made a video yesterday that you can find on the web page. In fact, when you see it in the YouTube page, this video that you're watching right now will be the first one before that second video I'm referring you to now. So you can get to that pretty easily. It's just one down from where this video is, by date order.
It's synthesis because it becomes one.
Two things are becoming one. So here we have hydrogen and oxygen, and they are getting combined to form water. Now, David, can you tell me, is this an element or an ion?
Element.
It is. Good. Okay. And how about this guy?
Element.
Okay. Now, is this an element or a compound?
Compound.
Compound. Okay. Now, this isn't strictly ionic, but we have to look at the charges on these guys because they will have charges, and that's the only way we could put together the Lewis structure. So we will look back here first, and synthesis is the name of the game. But there's also something else that it can be. And let's have Aaron, would you answer this one? Yeah. So what do you think this, can you classify this in any other way? Huh? Oh, combustion.
Yeah.
Is that what you're saying?
Yeah.
Combustion. Okay, good. That's the next one that I put down. And why is this combustion? No, that makes it synthesis. Huh? Oxygen. Okay. Where does the oxygen have to be to make it work as a combustion reaction?
The left side?
Yes, it has to be on the left side. So if you guys haven't got this already, I noticed on a lot of people's papers where they had oxygen on the right side, they called it combustion, and that's a natural mistake because they didn't realize that the O2 has to be on the left. If the O2 is over here on this side, yeah, you see you got oxygen over on the right side. But if we had O2 on this side instead of on this side, it would have O2 as a product, but it would not be combustion. Combustion requires the oxygen to be in the reaction. Where the action is, okay, and the action is on the left side because the hydrogen here and the oxygen are going to come together. And that's a very easy thing to do. It only takes one spark. And just like the Hindenburg, you're toast. Okay, because that's going to explode. And when it does explode, it makes water. Now that doesn't help you a whole lot when you're dead, but it does make water. Yeah. Okay, so oxygen, as it says right up here, must be a reactant. Cannot be anything else. Okay? It can't be just in the molecule like it is here. It has to be O2. Not only does it need to be O2, it has to be on the left. Okay? So I hope that clears it up for you. There is probably some misconceptions there. This is the one where we're going to have the fun. Because why is this oxidation reduction? Correct? Correct? What? Don't know? Have you got your notes from yesterday? Okay. What do your notes tell you oxidation reduction is? What do you have down for your notes on oxidation reduction? Okay. And what are the letters that go with that? In the letter form, you know the red letters that I had? Okay, plus O2. And now, do you have any reason why that is oxidation other than that formula? That's combustion. Oxidation reduction. Charge on the ions. What happens to the charge on the ions? They change. Okay. Now, here's where I got my big surprise, where I realized that I hadn't been teaching this quite as well as I needed to. All right. Class, what is the charge on hydrogen in H2?
1 positive. 1 positive.
Oh, we have dissension in the ranks.
Oh,
Some
no,
say
wait.
0, some say 1 plus. What is it?
0.
Why is it 0?
Because it's an element.
It's an element. Yes, it's an element. Now, when the element forms an ion, it does what? What's happening when they form an ion? They gain or lose electrons, and they get a charge. Yes, they do. Okay, so if they gain or lose electrons and they get a charge, then they're an ion. Now, can you have an ion in H2? Could H2 become an ion? No. Why? Because it has equal sharing. Okay. Is the electronegativity of these two guys any different? How about the electronegativity of these guys? Is it any different? They are equal. They are equal because they're both oxygen. Yes, Zoe. Because you get this guy. That's a covalent bond, and yes, technically it is not an ion. You're absolutely right. But you have to put atoms together, even in covalent bonding. You put them together in such a way that you will have the right number of electrons to have everybody have 8, except hydrogen, boron, hydrogen, beryllium, and boron. And then you have to have the charges match. Well, to figure the charges, hydrogen is, when he forms an ion, is going to be a 1 plus, and oxygen, when he forms an ion, will be a 2 minus. And so we think of that in the same way we think of as an ion. Okay? So, but you're right. You're absolutely right. The definition where we say the ions change their charge, that really isn't the best way to think of it. But there's a movement of electrons. And the movement of electrons goes from hydrogen to oxygen in what's called the partially positive end and the partially negative end. Okay? Whenever you get a dipole, you get that kind of situation. So the movement of electrons happens when these two guys come together, and it's explosive. And this is much more stable than this. So all I need to go from here to here is 1 spark. It's over. You know, and the whole Hindenburg blimp, which is as long anyway, as this building, that blimp was full of hydrogen. It only took 1 spark. And all of this very unstable stuff, the hydrogen and the electron, hydrogen and oxygen, They got together. Oxygen from the air, hydrogen from the Hindenburg. Perfect match. And everybody on board was toast. And it happened fast. Okay, no survivors. So over here, at least I don't think there were. If there were, it would be an absolute miracle. I mean, if the flames didn't kill them, then a drop would. Yes.
So is the Hindenburg like cold water?
Sort of. Yeah, but the heat would have the water evaporated. Just like happens on your stove. When you put a pot on the stove and you turn on the gas burner, okay, methane and oxygen form water, just like these two guys form water. Okay? And that's one of the products of the reaction. And you'll see the water condensing on the side of the pan. And you'll see little droplets of water. They stay there until the pan gets hot. When the pan gets hot, water evaporates, all gone. Yeah, kind of neat to understand how that works, isn't it? Yes?
When the water evaporates about H2O.
Oh, absolutely. It's just changing state. What are the three states of water? What do we call the three states of water?
Vapor.
What's the solid?
Ice.
Ice. What liquid is? Water. And the gas?
Vapor.
Vapor. Or steam. Yeah. Yeah. You can't see steam. No, you can't. Steam has no, you can't see it. You're saying that the clouds are not steam, or I'm saying that the clouds are not steam. The clouds are little tiny droplets of water, liquid water. They're very, very small, but when they when enough of them get together and condense, that's when you get rained on. Huh?
They exchange electrons.
No, they don't exchange electrons at all.
Charges.
They're just going through a change of state. That's all.
So why is it white?
Why is it white? Because of the light coming through. And it's water. I have pictures that I took at a parade, the convenient Christmas parade a couple of weeks ago, and it was drizzling at the end of the parade. And when I took a flash picture, it looked like it was snowing.
Can we see it?
It did. It looked like it was snowing. And the little water droplets were reflecting the light back. It was so cool.
Do you have the picture?
In Cavina.
Can you show us?
Yeah, I'll have to get that picture for you. But for right now, understand that's what the situation was there.
Wait, where was that?
In Cavina.
Oh.
Cavina Christmas parade. Anyway, so this guy is our oxidation reduction and combustion because it has oxygen on the left side, and synthesis because one and one come together to form a third thing that wasn't there before. We didn't have water when we were over here. When we were over here, we had water. Now, we're going to come to this second reaction. And let's see what that is. And let's get Sisyan to tell us what that is. Oh, you weren't here for the last couple of days. Okay, you need to watch my videos. I took videos both. Well, there's videos in both homework pages. Okay, Sergey. Yeah. Okay, what kind of reaction is this?
Decomposition.
It is decomposition, and why is that?
Because there's.
How do we describe decomp? One
One
forms two. Yes. So the one is water, and the two is hydrogen and oxygen. So these two reactions are the opposite of each other. So decomposition and synthesis are opposites. And you can think of this as a nut and a bolt, because it works real well with this reaction. Let's make oxygen the bolt, and the nut is going to be hydrogen. Does everybody know what a nut and bolt are? The nut screws onto the bolt, and it holds two things together. Okay. When you have the bolt or the nut here and the bolt here, you have two separate things. When you put them together, these are two separate things, and when you put them together, you have this. And so the nut is screwed onto the bolt, and that is a whole different thing. All right? Now here we have the nut and bolt together. Over here, they're separated. That makes sense? So synthesis and decomposition are the same. So what else can the reaction be? It's one of the three that are up above. Let's ask somebody. Anahit. Yay! Lucky you. Okay, Anahit. What else could this guy be?
Red oxidation.
Yes, ox-redox. Yes, ox-red. Yep. And it's ox-red because?
So it changes charges.
Yeah, you got charges changing. Okay? So, Anahit, what's the charge on hydrogen in this guy?
What?
Hydrogen is in a molecule over here. What would his charge be? Good. And what would the charge here be?
-1.
He's in column 16. Okay, so when oxygen, the element, gains 2 electrons, he becomes a 2 negative charge. But oxygen was balanced and neutral before he gained the electrons. I don't appreciate the side conversation. We're conducting class now. Did that make sense?
Mm-hmm.
Okay. Now what's the charge, Anahi?
0.
Okay, good. What's the charge?
0.
Yes. Hopefully this is starting to make sense to some of you. And hopefully all of you will get it sooner than later. All right, I'm going to go into the homework. So get this page out, and I'm going to start doing your homework problems. And we'll do as many of them as we can possibly get to. Okay?
Sir,
Yes?
are you through the whiteboard?
No, you have to look at that online. You don't have to have it for your notebook anyway. Yes? Why was what? Yes, I know. All right, let's go at it again. Was this the charge that you were concerned about?
Yeah.
Okay. This is the element before he formed the ion. So he has no charge. He's 0. All elements, as they exist on the periodic chart, have an equal number of protons and electrons. So if I have hydrogen, which I'm pointing to right now, he's in column 1. So hydrogen, the atom, gains or loses electrons. In this case, he's losing electrons. He's one electron. He only has one, right? So when hydrogen, the atom, which is in this form right here, okay, when he loses that electron, he takes on a 1+ charge. But hydrogen, before he did it, and to look at him again over here in the Lewis structure, you'll see that these guys have the same electronegativity because they're the same atom. Okay? Did I answer your question? Good, good. I'm trying to get the habit of saying it in a slightly different way than I said before. So, that's good. Let's move on. This page is going to be necessary because of these guys on the bottom. You're going to need this list or you won't know what things to put together for your homework tonight. So, I'd like you to take a minute and copy down the top of this form. Okay, now I'm going to model your homework for you by actually doing some of your homework problems, and I'll explain along the way what you're doing is something you've never done before. You are creating a skeleton equation. Okay, and what you have to work with is the reactants in the skeleton equation. So, if you're looking at that paper that we were just showing, you're going to see that our first reactant is, and let's do this, because we're going to need to classify, and then we're going to have number 1 with number 2. That's going to be our 2 reactants. So number 1 is lead 2 nitrate, PbNO3 twice, and you're going to have The next guy is 2, and that's iron FeCl3, iron 3 chloride. And then you got to come up with the products. And that's what you've never done before. Yes? Oh yeah, yeah, this identifies what the two, this guy right here, just a moment. Okay, this guy right here is identifying that we have number 1 on our list of chemicals, which is lead 2 nitrate, and number 2, which is iron 3 chloride. So here's our lead nitrate, here's our iron 3 chloride. Yes, Zoe? The space before the 1W2 is where we're going to classify it. Classify it as some kind of reaction. So let's go on over and figure out the other side. Here's what you want to do. You want to figure out what your cations are. Now remember the cations? Little kitty cat with a plus on his nose? Yeah.
What?
A little kitty with his plus on his nose, that's a cation.
How is it a cat?
It's a cat. It's a kitty cat. What do you think? Come on. Yeah. Okay.
Nothing like one.
So, we've got our lead. So we've got to have lead on the other side. And we are also going to have iron on the other side. And so what I want to do is identify my cations on both sides. And this will help make this a little easier for you to see because you haven't done this kind of thing before. What kind of reaction am I going to have here? No? Double replacement. Yes, this is going to be double replacement. And in double replacement, we switch partners and dance. So, how are we going to dance? Here we go. Nitrate on this side is with whom? Iron. Lead. Okay, he's with lead. So, who's going to be with lead over here? I already got iron. What? Chlorine. Okay, chloride. And now we're going to start figuring out how many chlorides we're going to have with that lead. And what everybody is going to want to do is say 3. Of course, yes? Because it's 3 on the left. Wrong. 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 No, don't do that. Here's how you do it. Watch and learn. Okay, what's charge? You don't know what the charge on lead is because lead can be either a 2+ or a 4+. So how do we figure that out? That's the key to figure it out. Okay, so nitrate is what charge? Charge on the nitrate ion. 1 minus. Okay, folks, if you don't know these ions, you need to get them in your head. We're going to have a quiz on that right after New Year's. And so if I have 2 1 minuses, what's my total negative charge? 2 minus. Okay, so what does lead have to do so I can get 0? 2. Okay, and if he's 2+ over here, he's got to be 2+ over here. Because this is not oxidation reduction. Okay? Now, here's iron. Iron is, we don't know, because he can be 2, 3, or 4, or, you know, you got different charges here. So, what's charge on chloride as an ion? -1. 1 minus. Okay. So, if I have 3 -1s, how many positives do I need for 1 iron?
3.
Yes. So this is iron 3 chloride. Now, who's going to be with iron on the other side?
NO3.
Yes, nitrate. And that's a 3 there. It's a little hard to see that I keep trying to fix it and it keeps making it bad. Okay. Bad to worse. Okay, let's see if I can make that a nice 3. There we go. Okay. Now, wait a sec. I don't know if I need parentheses till I figure out something. And so we're going to start with the iron chloride right here. And what was the charge on chloride? 1 minus. Okay. What's the charge on chlorine? Anthony, I want you to move back here, please. This is not working. Please go back. So, this guy, I've got to know what my subscripts are. Guess what? Remember the crissy-crossy?
Yeah.
Crissy-crossy, crissy-crossy.
Okay.
Okay, we're going to do that crisscross right here.
Is that what the X is for?
Now, what is the subscript going to be on lead?
1.
1, yes. And chloride?
2.
Yes. Isn't that easy? Now, let's do iron. Iron over, whoops. Keep doing that. I'm getting better, but I still do it from time to time. All right, so we're looking for iron. So iron over here is 3 plus. So over here, he has to be the same charge. And nitrate on the left side, there he is, okay, and so over here, he's going to be the same charge. So he's a 1 minus. All right, so what's the subscript for iron?
1.
1, yes, and for nitrate?
3.
And for that, we've got to package it. Okay?
Remember, so what are the X's for again?
Were the what?
The X's.
What X's?
On the chart.
Oh, don't worry about that. The X's on the chart we'll talk about when we do the lab. It'll make sense then. Right now it's not worth it. Okay, let's move on.
Okay, we got.
Yes?
How did you get 1W2?
1W2, because I'm doing everything on the first row of this chart that we just looked at before we saw this slide. Okay? So, let's I guess we ought to do it here on, no, what are you doing? There. Okay. So we're going to do on paper what we did, or what we're going to do in the lab. So we are going to be mixing chemical number 1 all the way across. That's our lead nitrate, right? In this box right here, which we'll have on a piece of acetate, we will put a drop of the lead nitrate, which is number 1, and a drop of the iron chloride. And we're going to see what happens. Okay? Then we're going to have lead nitrate here, 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 all the way to 12. All right? So, what we're doing is we're seeing what the actual chemical reactions are that are going on when we make those 2 drops come together. Does that make it clear? Okay. So, what do you think the next step is going to be here? Oh my gosh, come on. Here, let's get over here. Okay.
1 with 3.
Yes. So this guy is going to be 1 with 3. Yes. And on the left side, we're going to have the same stuff. Oh, we haven't balanced the equation. Oh, that's really fun. This is so easy. Watch and let's balance it in blue. What the heck? I am going to circle the subscripts of nitrate on each side so that I can balance nitrates. And I'm going to balance nitrates with the crisscross. Crissy-crossy, yes indeed. So, if the nitrate over on this side has a subscript of 3, and the nitrate over on this side has a subscript of 2, I am going to go ahead and put in a 3 here and a 2 over here. Okay, don't worry about the iron and the lead. Worry about the anions, the negative dudes, and that will take care of them as well, as you will see in just a moment. Now, we've got chloride with a 3 here and chloride with a 2 here. So, what is the subscript that I'm going to use in front of iron 3 chloride on the left? What am I going to put there? I'm going to put a 2 there. You betcha. And I'm going to do it in blue. 2. And what am I going to use for the coefficient over on this side? And this is a 3. And now watch. This is so neat. Lead and lead on each side. Come on. Here and here. We have a 3 lead here, and we have a 3 leads here. 2 times 3 nitrates. 3 times 2 nitrates. 6 and 6, right? Okay. 2 times 3 chlorides. All right. And 2 times 3 chlorides. And so we have 3 leads, 2 irons, and everything balances out. We didn't have to worry about the leads and the irons. They took care of themselves. Isn't that sweet? Okay, here we go. Lead, nitrate, twice, just like it was before. And then we're going to have, who is our famous number 3?
Are you gonna have this downloaded on the
Aluminum
website?
Yes. What? Aluminum sulfate, yes. Al3, oops, no.
So you're gonna have this on the website, right?
Al2, yes, I said I did.
Okay.
Al2, and then we're going to need a parenthesis because we got to make sulfate into a little package, and that's going to be a 3. Notice aluminum as a ion. Aluminum is up there in column 3. When he loses electrons, what does he become as a charge? He's column 3. Everybody in column 3 is the same. 3 positive. Yes, 3 plus. So this guy over here is a 3 plus. And let's put a box around him because we're going to need that, at least for now. And we already know what our lead is. Our lead is the same as it was in the last one. And we got a 1 minus here. And then for sulfate, what is the charge? This is one you had to memorize. This guy is a 2 minus. Okay? And now we're going to come on over to the right side, and we're going to have our lead. And who are we going to have over in this position? This aluminum. Okay, our cations. You want to do your cations first. And just for this exercise, you won't do this forever, but just for this exercise, box your cations, your positive ions. And those guys will stand out for you when you're doing your switch partners, because the partners you're going to switch are the anions. Okay, and your anions are, in this one, the sulfate and the nitrate. Okay, so now on the right side, who's going with lead? We had nitrate over here. Who are we going to have them with here? Sulfate. Yeah, you see how easy it is to see? So we have a sulfate here, and let's get the charges out. That's SO4. And the charges now for lead is still, ooh, not 2 minus, 2 plus. Yeah, 2 plus over here. And what is sulfate? Same as he was on the right, 2 minus. Okay, when I do a crisscross on this, should I put subscripts of 2 and 2?
No.
Why?
Because they're divisible.
Because they could be divided by 2, so I want the smallest possible ratio. Alright, so these guys will have no subscripts. Aluminum is a 3 plus, and I didn't put my plus in here. Sulfate, and then, I don't have a plus. Eek. I gotta put a little tiny plus in there. Oh, that's gonna be confusing, except on video. Hopefully. Oh, what a mess. Come on. Here we go. Make it smaller. There we go. That got him. Okay. And I think we'll just move this little dude over. There we go. That gave me the space I needed. that worked. And we need a plus between these guys. And the aluminum is boxed. And we put a, what over here?
Nitrate.
Nitrate, NO3. And now, what's charge on nitrate is a 1 minus. Okay, what's our subscripts? Aluminum has what? No, aluminum does not have 2. How could he have 2? You don't have that as either charge. 1. Okay, and nitrate? 3. There you go. Now we do the crisscross for the balancing, just like we did in the last one. Let's deal with the nitrates first. Okay, I have a 3 here, and I have a 2 here. So what is this going to be? Yeah, this is going to be a 3. And what are we going to have on the other side with the aluminum nitrate? 2, yes. Okay, and let's look at sulfates. Sulfate, we have a 3 here and a 1 here. Aha. So, what's the number in front of aluminum going to be for the sulfate from the right side? 1. Okay. And looking at the 3 from here, what's the coefficient going to be with the lead sulfate? 3. And notice again, isn't this cute? Get that up a little bit. Okay. If you look over here, you see 3 leads. Over here, you see 3 leads. Aluminum 2, right? Because the coefficient is 1. Yeah. And here, aluminum is 2 because the subscript is 1 and the coefficient is 2. Yeah. All right. And we have 6 nitrates here because it's 3 times 2 is 6. We have 2 times 3 is 6 over here for the nitrates. And the sulfates on the left are 3 times 1. Sulfates on the right are 3 times 1 sulfate. We're good, huh? All right, let's do one more.
Oh, but what's the reaction?
Oh, what kind of reaction is this? Still double replacement. All right, let's move on. And let's go here. And 1 with 4. And we're going to put lead and nitrate. And we're going to have aluminum. Oh, not aluminum. Who's number 4? Who's chemical number 4? Hydrochloric acid, yeah. HCl. And we're going to go over to the other side. We'll have lead. And with him, we'll have nitrate. And then we're going to have, let's see, hydrogen. This guy will be with nitrate. All right, we're ready to rock and roll now. Charges. 2 plus. This guy's still 1 minus. This guy's 1 plus. And chloride is a 1 minus. What am I doing here? Okay, 1 minus. And lead is what? It's still 2 plus. What's nitrate? 1 minus. So, what's the subscript for the nitrate?
2.
Yeah, this guy's going to be a 2. And over here, we have a charge of what for hydrogen? 1 plus. Nitrate is minus. Okay? So, we don't need any subscripts on this guy. Yes? What? Okay. Yeah, this guy's wrong. This. Oh, this is HCl. Oh, I see what I did. Oh my, I did a boo-boo. Okay, let's make this right. this lead is going to be with chlorine, and it's going to be 2 chlorides. And this guy is going to be with nitrate. There we go. That fixed it up. And the charges happen to work the same as well. So, just real quickly, the subscript for nitrate on the left is 3. So, nitrate on the right will have a 3. Oh, and 3 and 3, that's 1. Nitrate on each side is the, oh, no, it's not. Okay, so this guy right here is a 3, and that makes this a 3. This guy, oh, this guy, no, this guy.
Oh my gosh.
What did I do wrong?
You messed up so bad.
I messed up really bad. Here. Okay, so I made some mistakes, and I've got them fixed here on this screen. I had the wrong guy over here, so this should have been nitrate because nitrate was over here with lead before, and this guy is chloride because he was over with the hydrogen before. So we did a switch partners and dance. Now it so happens that chloride and nitrate both have the same charges, and so we get this interesting thing when we balance the equation with 1 and 1 here and 2 and 2 here. But at any rate, you'll notice here, as this guy is a 1, the subscript for lead is a 1. As this guy is a 2, the subscript here is 2. And then this guy here is 1 and 1, and we don't write the 1s, so it's just HCl. Here we've got a 2 plus, which gives us the subscript of 2 for the chlorine, a 1 minus, which gives us the subscript of 1 for the lead. And then on nitric acid, we've got a nitrate with a 1 minus and a hydrogen with a 1 plus. And because they're both 1, we have no subscripts here. This 3 is the 3 oxygens in the nitrate ion. So, over on the left side, we still want to label this as a double replacement reaction. And that's it. It's a long video, and I hope it's going to help a lot of people. And I hope you've just watched the stuff that you find that you need to understand.